Hey friends, I'm gonna do right now. I'm already gonna start, so I'm gonna get everyone to come right here. I'm already live, so but that's fine. I'm gonna just see if you guys can get a good view here. Let's see if I can get closer. All right. Think we're good to go. He's working on that, right? So, no, you're good. You're good. I wanted to go over something with you guys today. You know what? Oh, you guys are gonna stand there, so I'll just tilt it this way. Let me just make sure it's actually they can see it. Okay, so, whoa. All right. Yeah, you're good. You're good. All right. See ya. All right. See you tomorrow. You have a good night. Take care. Take care. All right. See you tomorrow. Yeah. So I wanted to go over this a concept. I think, to be honest, this took me about 6 months to learn, just because no one would tell me, like, 1 + 1 = 2. I know that. Why are you telling me that 5 - 4 = 1? Just tell me the easy way of understanding this. It was just overcomplicated. I even had a conversation with, it's funny. So, and I forgot this guy's name, but he's like the electrician guru. I was watching a video on how to understand this. He was teaching it a certain way. Then I got someone to come in. He's kind of one of my mentors, 50 years in the field. He's been doing HVAC for a long time. When I told him about max fuse and minimum circuit ampacity, he's like, what that guy is teaching, and remember, that's the electrician guru, like, that's wrong. I even got the electrician teachers to come, and I'm like, okay, who's right here? Who's wrong? And what they were saying, and I respect that, they were saying, look, when I go to a job where I have to run power for an HVAC system, I just listen to what the HVAC contractors tell me to do, hoping that it's, somewhat accurate. But after a couple months, I finally kind of understood how the max fuse and minimum circuit ampacity work. So hopefully I can explain this in the next 20 minutes or so, because this is going to be important when you're running power to your air conditioning systems, whether it's a furnace inside your house or a package unit, a mini split, whatever it is, a condenser. You got to bring power in, right? But you don't know what breaker size it should be, or what about the wire gauge, right? The actual wire itself, how thick or how small it should be. All that matters. So the one thing to first understand is you got what is a panel, right? Where all your breakers are at. Does everyone understand what that means, or what that is? A break, yeah. Okay, I want to make sure, because if you don't, then it's going to be confusing, right? So everyone's good, right? So your panel is all the way over there. Your breakers are there. So you have high voltage power coming from the pole, right? From the city. It comes in a big conduit. It comes into the panel. And then you got breakers that distribute power everywhere, right? 30 amp breaker, 20 amp breaker, 50 amp breaker, whatever it is. But you see, it comes to this distribution location. And then it goes through breakers first, and then it goes out to different places, okay? So we're gonna use, I forgot where I got these numbers from, but we'll go over examples that we have here in the lab. But every unit that you work on, you're gonna see two things: minimum circuit ampacity, and then max fuse. Okay, so minimum circuit ampacity and max fuse. So the idea behind any install is that you have your panel where your breaker is at. You got to put the correct breaker, the correct wire size, and then the disconnect and the correct fuses and the correct wire size going to the unit. You see, it's a lot of stuff. It's a lot of little steps. So just to kind of emphasize the point, right? The breaker is to protect the wire, right? The breaker is going to protect from the breaker and the wire going to your disconnect, right? So your disconnect, right, is that right there, right? That's your disconnect. The fuses is to protect the equipment, okay? So just be mindful of that. We'll go over a little bit over that right now, but you got 2 disconnects out there. You got a 30 amp disconnect and a 60 amp disconnect. So these mini splits right here, these are smaller, and this is how it looks with, you know that these are the 30 amp disconnects because the fuses are small. Once you go past 30, like 40, 35, 40, 45, 50, 60, and you can tell that disconnect's a lot bigger, it takes the big fuses like this. They only have 2. That's all you're gonna be dealing with, right? You only have 2. Okay, so here in the United States, American wire gauge, I know it's gonna be, you know, HVAC's always the opposite, which I kind of hate sometimes. Superheat, subcool, why is it the opposite? With electrical, it's a little bit, it's the opposite in this sense. American wire gauge, the higher the actual wire gauge, the number, the skinnier the wire it is. The skinnier the wire. So think about your 24 volt circuit. Are your wires pretty thick for your thermostat? They're not. It's usually an 18 gauge, okay? Now when you're dealing with higher voltage, like for example, like your outlet power there, 120 volts, there you got a 12 American wire gauge. It's a little bit more thicker. But you see, as you increase the amp, you must increase the size. Because if you put a 30 amp breaker and you run 12 gauge wire, that wire can burn up or it can cause other issues, because more amp, it means what? More current. And what does more current mean? More heat. More heat. So you can burn the house down, you can have all these weird issues, but as you increase in amps, you have to increase with your wire size too. Okay? And I think that's kind of simple, right? But it's the opposite though, right? The lower the number, the thicker the cable is, and more expensive, of course, too. So, okay, so does this make sense right here, this part here? Okay. So what does this mean? The minimum circuit ampacity, max fuse. So right now, just take a minute, go around the lab, right? Go around the lab. I want you to see, and you guys can look at maybe, if you guys want, just this one here, that package unit over there. You guys can look at some of these mini splits. Just take a minute. We're gonna use this example, but this principle applies to all of them, what I'm gonna show you guys. So it took me 6 months to learn. But go ahead and walk around just for a minute. Look for those two things here: minimum circuit ampacity and max fuse. Okay, just a couple of seconds, and then just come back and we'll talk again. I want you guys to believe that those actually exist on units. Okay, that I'm not lying here. So go ahead and go around and look for that. And you're gonna notice that the max fuse is gonna be greater than your minimum circuit ampacity. So go to condensers. You can move that ladder if you want to. Yeah, go ahead. Go everywhere. Go ahead and check it out. The minimum ampacity is going to be lower than your max fuse. Okay? So understanding this is going to help you wire up your next, let's say you have a job, you know how to size it correctly. You saw it, right there? Yeah. Yeah, okay, good. Yeah. And did you guys find it over there too? Kind of? Should be on the plate there. Minimum circuit ampacity, max fuse. Good? You guys saw it? Or?
So yeah, 253 max and 197 minimum.
So the 187, that's your minimum voltage. You're gonna look for something that says max. So if that one's a little bit harder to look, just look at this one here. That's okay. That's it. Look, this one here is where is it? There you go. Where is it? Oh, right there. You're right. Minimum circuit ampacity 29.3, and then max fuse 40. Okay, so the panel's gonna have this, and we gotta look at this to help us size the equipment correctly. So now that you know that every unit's gonna have that, all your mini splits are all gonna have that. So now it's like, okay, so now we have to size the equipment correctly, right? From the breaker, wire, disconnect, fuses, and then wire from the disconnect to the actual unit, right? It's a lot of stuff. Now, I didn't know this for a long time, and it makes sense, but why is there a big difference between minimum and max fuse? So in this specific example, your minimum circuit ampacity is 20.5 amps, okay? I don't know where they got this number, but how they calculate the 35, they times this by 156%, okay? I don't know what engineer came up with this, but it makes sense once we do the math. So your minimum ampacity, minimum circuit ampacity times 156%, 156% equals your max fuse. Okay, it's gonna make sense right now. So let's say the minimum that unit is gonna pull is 20.5. So let's say the condenser coil is clean, the evaporator coil is clean, all the motors are working right, it's not overcharged. It's not like if it's a really hot day, it's gonna work more harder, right? So current's gonna go up. So, but on a normal day, it's telling you it's gonna pull about 20.5. Your compressor's gonna pull maybe, this is just examples, right? 14 amps. Your motors and all that is gonna pull 6. It's close to that 20.5. But that number can change because on a really hot day, and if you don't do good maintenance, that amp draw is gonna go up. And the way they determine this is they take this number and they times it by 156%. So to times 20.5 times the 20.5 to 156%, how do we do that? What do we have to do with the 156%? We got to convert it to what? A decimal. So what would be the decimal of 156%? 1.56, okay? So let's do the number. Get your calculators. 20.5 times 1.56. 20.5 times 1.56. What is it? 32? 31? 31.98?
Yeah.
31.98. So it's not 30 because we're already above 30. What's the next closest number? And they go by fives? 35. So that's why this is how they figured it out. They're like, okay, let me go ahead and do the math. Times this, it's 32, close to 32. Well, I can't go 30 because that's lower, so let me go to the next highest, 35. So they're saying your max fuse should be 35, okay? Now this is where it gets a little tricky, and just bear with me right here with this example. I actually learned something today, I guess it's a new code I wasn't aware of, and I'll explain what that code is. But here, man, it smells like that bread, huh, right now? It smells good. I was telling the morning class that we should go, because they only sell in bulk next door, we should go just get a sample. Because we have a lot of people that are interested, and then possibly buy in bulk. But I think one day we gotta go get some of that, whatever it is, man. It smells.
Yesterday we didn't smell it.
You can smell it. It smells. Oh no.
Yeah, yesterday no.
I think today is that, man. They're harvesting today. Okay. So you're not gonna completely ignore this number, but this is a number you're gonna be working with now. Okay. This is it. 35 max fuse. So when you come to your breaker, okay, it's easier to get 20, 30, 40, 50 amp breakers. Can you get 25, 35, 45? You can, but it's easier to get those 10s. But you could find the 35, right? But just bear with me with this example. So if I were to just, let me erase the 40 for now, okay? So the way I would do this, put a 35 amp breaker, right? You got 2 wires coming out, and then you got your ground, right? One of them has to be the ground, right? 35 amp breaker. My wire gauge, it's gotta be 8, because we just said 30, between 20 and 30, that's 10. We just went over 30, we gotta go with 8, okay? So put 35 amp breaker, run 8 wire, right? Come to my disconnect, and this is where it's important. Max fuse, 35. So you would put 35 amp fuses with 8 American wire gauge. Can you do this? Can you put a 40? Yes, just bear with me, okay? You're like, but it's 40. It's gonna exceed the 35. Remember, the breaker protects the wire. The fuses though, as long as I don't put 40, the fuses are gonna protect the equipment. If there's a short to ground or something's going on, this is gonna pop. The fuses are gonna go bad before it's gonna pull more. Like if it pulls 36, whatever's going on, the fuse is going to go bad. It's not going to allow it. So you could technically put a 40. Now, can you put a 50, 60? I mean, that's overkill. Why would you do that? Why would you increase the wire? You want to get it as close to that number. We want 35. The crazy part is that right here with the wire, the lower the number, the thicker it is. I can go with 4. I can put 2. Now, that would be really thick, but it doesn't matter. You would think, wait, that's more voltage, more current. It just means there's more copper strands, but it's still going to deliver the same amount of voltage. But guess what you're going to be spending money on? Money. Right now, copper is very expensive. We would put a 35 amp breaker, 8. Or if you can't find 35 amp breaker, you could put a 40, right? 8. And don't worry about it being off by 5, because the fuses that you're going to put have to be 35 though, because it just sets max fuse. So 30 amp fuses going here to your unit. Now, I was talking to a buddy of mine today. He was just saying that now inspectors, and this is how I've been doing it, where I'm okay running the 40. The inspector basically said, you got to match the max fuse has got to match the amp, the breaker. It's got to match the breaker. Remember, we can do both ways, right? 40, it will still work because the 35 amp fuses will protect it. But he was just saying, now inspectors, they want this to match that. I'm like, oh man, that's crazy. But you know what? They do sell 35 amp breakers. They do. And so get it, run your wire, 30 amp fuses, and 8 as your wire gauge. So does that kind of make sense? A little bit. If you're still lost, it's okay. We're going to go over some examples here. But that's the idea. Fuses to protect the equipment, breaker to protect the wire. You don't know if these wires are going to touch it one day, right, to the conduit. So you got to have the breaker to protect it. If you don't have a breaker, you're gonna mess up the actual voltage coming from the city. Like, it's going to create some weird stuff. You got breakers that trip. Something happens here where they touch, or the unit itself is pulling more. There's a short to ground or a dead short to each other. The fuses will go bad. Certain times when it's really bad short, I have seen it where it takes the fuse and it trips the breaker. At least it did its job though. It messed up the fuse and the breaker, right? So, and I have a video tomorrow I'm going to be uploading, but it's not short, high voltage shorts, it's low voltage shorts, but it's the same concept, right? Something's happening where it's pulling too much amps. And typically it's the motor just grounded to each other, right? Remember the leg 1, leg 2, both carry power. They got to go to a load. Something happened where like that load shorted to ground. What is this wire? They didn't screw it and now it touches the metal of the unit. Because we have a ground wire coming, it's gonna trip. It's gonna your 30 amp fuse is gonna go bad. So that's the idea behind this. So now let's do a couple of examples. Let me see, Brian. Let's do this first one here, okay? Minimum ampacity is 17.9, and just for giggles, so you guys believe what I'm saying. Times the 17.9 times 1.56. Watch it. Get close to that number. Watch. Just do it. 17.9 times 1.56. Should be like 28 or something. Or 17.9 times 27.9. Okay. The next number is 30. That's how they calculated the max fuse. So for my breaker right here, double pole breaker, what breaker size are we going to use?
You can use like
35? I can use a 30 though, right? Because it doesn't say 30.5, right? It's 30 amp breaker. What about the wire?
The wire you can use a 10.
10? Good job. 10 gauge? Or lower, but then you would spend more money. But you could go lower if you want, if you got the money. What about the fuses?
For the fuses, you can go 30 amp.
Good job. The little, these right here, right? What is this? This is, 30 amp fuses, right? So put 30 amp fuses. And what about the wire coming out?
You can use
10 gauge, okay? Typically, when you buy this, they sell it in a whip. It comes like an actual flexible whip, and it's already 10 gauge. But if you have to do 8 gauge, then you wouldn't buy that one in the first place, because they already come like with the wires and all that. you would have to get, you have to make sure it's 8 gauge if you exceed the 30. But that's it. That's all you just sized it correctly. Now, I will say this, there's a lot to electrical in the sense that, for example, outlet, 120 volts, right? They typically run a 20 amp 12 gauge, that's it. It gets to the point though, if they have to run that circuit all the way, let's say all the way over there, what do you think happens? There's not gonna be enough because voltage drops. There's more like resistance, voltage drops. So in that case, it is possible to find a 20 amp breaker with a 10 gauge wire because you have to increase it. So be mindful, and there's apps that can do that for you. But be mindful, you might have to up a size sometimes if you travel long. And you can check it. You can come to the other side and check voltage. It should be at 240. You're like, oh dang, it's at 220. Now at that point you kind of messed up because then you have to rerun the whole wire. But you can get creative. There's a electric test that you can do where before running the wire, you got the whole spool of wire, you can do a resistance test. And there's a certain number you're looking for, but there's apps that will literally tell you what's the max fuse, how far is the distance, what's the voltage, and they'll tell you what wire to use. Just be mindful of that. You can use those apps. Let's see, Aiden, what do you think right here? 30.5. So when you do the 30.5 times 1.56, it's close to 50, right? But what should we run? What kind of breaker should we put here?
For the 50?
For the minimum ampacity is 30.5, max fuse is 50.
50 amp.
There we go. That's it. 50 amp breaker. Okay. And then so we're gonna put it here, right? 50 amp breaker. What about the wires coming out?
6 gauge.
Good job. 6 gauge. And then on the disconnect, what kind of fuses?
50 or 60. Well, could you do 60 amp or does it have to be 50?
You would do 50 because the actual panel is telling you max fuse is 50.
Yeah.
So then you get the little 50 amp fuses here. And then what wire coming out?
6.
That's it. So yeah, you wouldn't want to go 40 because it's like, well, I need more juice, I need more current. What if I pull more than 40? But then if you put 60, there's nothing stopping it and something can happen to that component. I'll mess it up. So 50 is that cutoff. I don't know, who wants to try this one? You want to try it? No, actually, yeah, I think you're probably going to get it. You're just like, I already got this down. Let's see, Reed, you want to try it? So what, this is a little bit, it's a little tricky, but it's okay. We'll go with it together. So what breaker size would you use?
35.
That's it. 35 amp breaker. Okay, and what size?
8 gauge.
Good job. That's it. Yep, 8. And then right here?
35 amp.
Dang, you got it fast. Good job. And then the wire?
8 gauge. 2 amp.
That's it. 8 gauge. Now, like I said, technically, you could put a 40, right? You could, because you're protecting it over here. But according to what I heard today, I don't know when that's gonna, I don't know if it's into effect, but they want this 35 breaker to match the amp fuse. So that's it with this, right? I mean, if you ever have to install, do a unit, this is important. You don't know how many times houses burn down. You don't know how many times fuses go bad, and you're like, why? And you look, and you're like, oh, it was wired wrong. Last note before you guys go on your calls, I had a job actually it was more than a year ago, but it was, that one here it's a 40 amp. It was a 40 amp max fuse. I forgot, I think it was 20.5 minimum ampacity. And this is what they did. That was it. And what they ended up doing, they ended up putting a 25 amp, what is it, 10? Yeah, they put a 25 amp breaker. And it had 10 American wire gauge, okay? That's what it had. It should have had a 40, but that's what it had. So guess what happened on a really, really hot summer day? That breaker tripped because it pulled more amps. So then I come and I'm like, oh man, I gotta upsize the breaker. So can I put a 40? Right? Can I put a 40? I'm good?
No,
There we go. I can't, because unless they replace the whole wire, but they didn't want to. So in that case, all I could do is put a 30. And I haven't heard back. And if they want to do it right, they would have to redo the whole wiring and put a 40. But I am not going to put a 40 amp breaker, because if that house burns down or something happens, it's on me. Because it's going to pull more. At least I'm going to stop it. The fuses too, I had to change them to like at least 30 amp. I can't go higher, 40, because this is the one that bosses, the boss, right? But I'm sure it pulled like 29 or 28 on a hot summer day. But yeah, too low. And it worked. So just be mindful of that. So any questions with this before we end it? Does that make sense? Yeah, right? I actually drew better than the evening class than the morning class. The morning class was terrible, bad penmanship. So feel free to take a picture of it or whatever. But good. I wanted to make sure that it made sense to you guys, because you're going to find yourselves doing that. And yes, bending conduit, pulling wire, that's a whole different thing. Getting to the disconnect. But now the knowledge that's what comes in handy. That you can learn, They'll teach you. Or I got $50 worth of conduit. Went to my garage and practiced. That's how I learned conduit. And I'm not the best, but I can get by. But, you do what you got to do. So, cool. Cool, guys. Yeah. So, I think, what is it? You guys, did he have you guys go over on that unit over there? You guys were on that unit? You're just, I might have something else for you, Rito. Brian, you're going to go here. Andrew, I think you were going to go. He's going to have you work on the plenum. Alex, did he have?
Yeah, is it cool if I go upstairs and do that electrical thing?
Yeah, absolutely.
I already did it, but I just want to make sure I'm good.
Go for it. You can go do the boards. Yeah, you go over there and then read. I'm going to give you that unit right here. Right here. So, all right, friends, you guys have a good evening. I will catch you on the next one. Thank you for your support. Hopefully that kind of made sense for you guys. Feel free to take a screenshot if you want of that. I'm going to leave it there. Go ahead and take a screenshot of that, and hopefully it helps. And we are located in San Dimas. This is where we're at. We're in San Dimas. So the school where I work at, HVAC Training Academy, there is a website you guys can go to, and they'll give you more information and a number to call. But awesome. I appreciate your support. Yeah, California, San Dimas, California, by Los Angeles. This is where we're at. So we're gonna eventually try to teach refrigeration, and I have a couple months from down the line, I'm gonna try to teach building automation. I try to teach building automation on the side. Yes, thank you, founding subscriber Ethan. I will say you were my first subscriber. I'm not a contractor. I don't own my own company, but I am getting my C20 soon. But I don't know if I'm gonna go that route with the company yet. I'm still debating that, so I'm gonna have to see. But I'm gonna turn in my paperwork. HVAC Training Academy. Go to Google. Just go to Google. Type in HVAC Training Academy, and it's gonna be the one in San Dimas, and there's going to be a number, and if you wish to get more information, just feel free to look us up. And then there is HVAC Training Academy. Our email, I have to remember the actual email, but yeah, check it out. Okay, I'll catch you guys next time. I gotta go back to the students, but I'll see you guys on the next live. Tomorrow I will be posting some long videos and some shorts. So stay tuned to those.